Hi guys, I hope you all are doing well. So today we'll be starting with our class 9th fourth chapter, that is exploring algebraic identities. So lastly, in the last session we covered our chapter 2. But yeah, we are skipping the chapter 3, that is the world of numbers. That is because it is a very basic chapter, and you may read it from the book and you can understand the chapter because it is very simple, small, cute chapter that has rational numbers, natural numbers, and what are rational numbers, what are irrational numbers. So yeah, that is very easy chapter. That is an easy chapter, so you can do it on your own. So today we'll be starting with the chapter 4, that is exploring algebraic identities. So earlier you have in the last chapter we have in the second chapter we have learned what are linear polynomials, how do we solve linear polynomials, what is the use of linear polynomial, right? So today in this chapter we are going to learn about some identities that we use in mathematics to make calculations easier and to make calculations convenient. Okay, so firstly, we'll be starting with our first identity, that is the whole square. I'll just write it down. So the identity is A. Just a second. Yeah. So the identity is A plus B whole square is equal to A square plus 2AB plus B square. Okay, so this is our first identity. That is A plus B whole square is equal to A square plus 2AB plus B square. You may understand it through visualization that if, let's say, uh, this is the square of side A. Okay, you know that the area of square is side into side. Okay. So we first for the smaller care, for the yellow part, the square is of side A. So the area of yellow square would be is equal to A square. Okay, understood? Cool. Next up we have a very small, we have a rectangle. You can see over here that is of side, like yeah. So we have just added one a small side to the square A from both the sides of length B. So yeah, you can see that here also we have added B, here also we have added B. Okay. So the whole length from this point to this point is A plus B units. And similarly for this side, the whole length is A plus B units. Okay. So now if we want to calculate the area of green part, we can say that for G1, that is the green part of this one, we can say that it is a rectangle of length B and breadth A. So the area of rectangle is AB. That multiplication of both the sides. Okay. Then next up we have G2. For G2, we have length is equal to A and breadth is equal to B. So that also the area is A into B. And for the third part, for this part, we can say that you can see over here, if we extend this line, our side is here B and here also the side is B. So it becomes a square, or if you visualize it as a rectangle also, both the sides are equal. So hence it becomes a square. So the area of that pink part is B square. So now if you were to get the whole area of the whole square, that is A plus B, for the square of side A plus B, you would have to just add all these individual squares. So you can say that now our you know that the area of square is side into side, that is side square. So for us the side is A plus B, and now to get the whole area we just need to add all the individual squares. So we have A square for the yellow part. Then for the part one of green, we have AB. Then again we have AB. Then we have B square for the pink part. So that gives us a square plus 2ab plus b square. So this is how you can visualize it using squares. Also, if you were to expand the brackets, and you would have got the same answer. We'll expand it and let's see the answer. A plus b. We can write a plus b whole square as a plus b into a plus b, right? Okay. So now to get to solve this, we need to learn how to multiply the brackets. So what we have to do is take first part of first bracket, multiply it with both the parts of second bracket, then plus, then using the sign conventions obviously, and then take the second part of first bracket and multiply it with the both the parts of the second bracket. Okay, so now we'll take a. So पहले a लिया, multiply a with first part, multiply a with second part. Now a into a, that is a square, प्लस बिकॉज यहाँ पे प्लस है ए इंटू बी, ए बी हो गया, फर्स्ट पार्ट डन. नाउ नाउ मल्टीप्लाई द सेकेंड पार्ट, अभी बी है, मल्टीप्लाई बी विथ ए देन मल्टीप्लाई बी विथ बी. So if we multiply it, we get b into a, ba, plus b into b, b square. So therefore the answer is a square plus 2ab plus b square. I hope that this is understood. Similarly, we have the second identity, that is a minus b whole square is equal to a square minus 2ab plus b square. As we have expanded the first expression, similarly you can expand this also. What you have to do is write it in the form of a in minus b into a minus b. If you expand it, you will get this answer only. So this is a second identity. So now how do we use this identity? Let us say we are given two numbers. For instance, here we have given a minus 2 and b minus 3. Then if we were to find a plus b ka whole square, then what we have to do is minus 2 plus minus 3 whole square. So minus 2 minus 3 gives minus 5 whole square. Or else we can solve it in a similar way as a square plus 2ab plus b square, because it is in the form of a plus b. So what is our a? A is minus 2 whole square plus 2ab. So 2 minus 2 minus 3 plus b square. So minus 3 ka whole square. You know that the square of a negative number is always positive. So minus 2 whole square is 4. Then minus 2 into minus 3, we get plus 6, and plus 6 into 2, we get plus 12. So 12 plus minus 3 into minus 3, that is minus 3 ka whole square, we get is equal to 9. So if we write this, we get it 25, which is equal to minus 5 ka whole square, that is 25 only. Okay, I hope this is understood. And we have got the answer, right? So yeah, cool. Now, also next we need to learn that what is the difference between an equation and an identity. An algebraic identity is an equation that is true for all values of the variables occurring in it, while an equation need not be true for all values. So basically, this, let's say that we have an algebraic identity. अभी ये जो मैंने बताया, this is an algebraic identity. This is this is true for all values of a and b. You take any value, you may take it in fraction, in negative number, you may take it as a positive number, any value, this identity is always true. But equation is not true. If I would say that a minus b is equal to 2a, so there are only some certain values that satisfies this equation. So that is why this is an equation, right? Okay, cool. So yeah. Next up, in this you have examples wherein you have to just expand. You may try this at your home. Uh, we'll not cover this because if you practice more sums and numericals, therefore you'll get used to it, and you'll also know how to multiply the brackets and how to use the sign conventions also. Cool. So next up, you have exercise 4.1, that is very easy. You just need to find values. Okay, we'll take one example from this exercise. That is, let's say, uh, that is, you need to find out square of large numbers. Okay, so you are given 64. Abhi, just a second. Okay, so yeah, you need to find the square of 64. Now, squaring 64 is a huge number because you need to multiply 64 two times, right? So it is a very tedious process. Rather, instead we can write 64 as 60 minus 4, right? 60 minus 4. I hope this is understood. Because 60 zero hai, so you know how to square numbers that ends with the numbers that end with zero. Like if we have 10, so just square the first number and write the zero two times, 100. If we have 40, then you'll have two zeros and square of first digit, that is 1600, right? So similarly, we need to find 60 minus 4 whole square. So basically, we will use remember the identity we learned, that was a minus b whole square. So we'll use a minus b whole square, that is a square minus 2ab plus b square. So if we put a is equal to 60, so here a is equal to 60 and b is equal to 4. So if we put a is equal to 60, then a square is 3600, right? Then we need to find minus 2ab because 2 into 60 into 4, that is 60 into 4, plus b square, that is 4 square, that is 16, right? So we have 3600 minus 2 into 60 into 4. So 6 4s are 24, 24 2s are 48, 480 plus 16. So if you solve this, I'll just quickly solve it. You cannot use calculator. Just for the ease, I am using it. You're not allowed to use calculator. So the answer is 3136. If we directly square both the digits, we also get uh my bad. Okay, sorry. I have just done a little mistake. I wrote it as 60 minus 4. We need to write it 60 plus 4 because we have 64. My bad. I'm so sorry. So nothing changes, only the minus sign over here changes. Plus plus plus. So just we need to add 480. So yeah, this becomes 3600 plus 3600 plus 480 plus 16. So that is 4096. You can see that 64 into 64 is equal to 4096. This is how you can find the squares of whole numbers using the identities. I hope this is clear. We'll just erase this part. One more use case of this identity is that we can use it to find factors of some algebraic expression also. You can see that we have an algebraic expression x square is equal x square plus 4x plus 4. We can observe that if we have we can write it as if we say that x is equal to a and b is equal to 2, then we can see that this is equal to a square plus 2ab plus b square, right? So we can write it as x square plus 2 into x into x, 2 into x into x plus 2. So, sorry, 2 into x into 2. So we can factor it as x plus 2 and x plus 2, right? We can write it as x plus 2 whole square. Okay, so this is also this method is used by observing is implemented by observing the expression and their squares and the all the terms in the expression. Okay, so you may try all the examples, you may read it, and you will understand what is given. So yeah, also mm, nothing. Next up, we have exercise 4.2 that focuses on mostly on a minus b whole square identity. For example, we'll just see one example, that is 79 minus 2. Okay, so 79 we can write it as 80 minus 1 whole square, right? So this can be written as let's say a. So this is equal to a square minus 2ab plus b square. So now a is equal to 80 and b is equal to 1. So 80 square is equal to 8 ka square 64. 6400 minus 2 into 80 into 1. So that is 160 plus we have b ka square, that is 1. So if we were to find the answer, 6400 plus 1 minus 1 minus 160. So that comes as 6241, and we can say that 79 into 79 is also 6241. So yeah, this is how we can write it. Next up, we have more identities to write. That is, now we have seen that we have only two digits in our calculations. What if we have three digits? So yeah, if we have three digits, we can write it as a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. You can take the two common and just write it as a square plus b square plus c square plus 2 bracket ab plus bc plus ca, right? So this is also an identity. This holds true for all the values of A, B, and C. You can write the proof. You can understand the proof using the textbook. You can read it over here. Just we have assumed, what we have done is we have we have written B plus C is equal to D. So therefore this identity becomes A plus D whole square. So if we expand this, we get A square plus 2AD plus D square, right? So if you again substitute the value of D, so we get 2A B plus C plus B plus C whole square. So here we can see that A square plus 2AB plus 2BC, right? We first multiply this, then we multiply this. Then B square, B plus C whole square, B square plus 2BC plus C square. If we write all the squared terms separately, we get A square plus B square plus C square. If you write all the terms with the 2 separately, then we get it as 2AB, 2BC plus 2CM. Rearranging all the terms, we get our identity. I hope you have understood this proof. Okay, cool. So you may visualize it using this square also. We have find the sides, squares, right? That is AB, etc., etc., whatever the area would be. Okay, cool. So this is our identity. A plus B plus C whole square is equal to A square plus B square plus C square plus 2AB plus BC plus C, 2CA, right? Okay. This is how we can use it to find the square of a bigger number, that is 119 ka square. If we were to find, then we have written it as 100 plus 10 plus 9 square. Then that is A, B, C. Now putting all the values, substituting all the values in the identity, we get the answer as 14161. Basically, these all identities makes our life easier, makes our calculations easier. Okay, so far we have learned these three identities. Make sure that you um, are thorough with it, and also you just did not need to rectify it. You get the proof as well. Like you need to learn the proof as well, that how we have derived the identity, and if you do not remember it in your exam, you can derive the identity again using the expansion. Okay, so first we have used a plus b whole square, that is a square plus 2ab plus b square. Then we have a minus b whole square, that is a square minus 2ab plus b square. Then third identity was a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus bc plus 2ca. This was our exercise 4.3. Okay, so next up we have exercise 4.3. You can solve it and get through the answers. Cool. Yeah. Last we have factorization using algebra tiles. That is nothing about, but you just need to multiply the brackets and get the identity. I'll just explain you how we can how we can get the factors using splitting the middle term method. Maybe like I'll take an example. Oh, right. I missed one part. Yeah. So also we can write to find the factors. We can write if we are given some number that is, let's say, we are given 4x square plus 16x plus 4. So basically what we can do is this algebraic expression is equal to x square plus, I'll just erase the coefficient, x square plus a plus b x plus ab. So this is the basically you can equate it with this, but you need to focus that you need to focus that you need to look at the variable or at the coefficient of x square that needs to be 1. So if we equate this with the standard form, we get it a plus b is equal to 16 and AB is equal to 4. So we need to find the values of A and B such that it satisfies this equation. So now this was this was a hypothetical example, so we don't have such values that satisfies this equation. If we were to find, then just put B is equal to 4 by A. Where if we write B is equal to 4 by A, but वो नहीं आएगा. 4 by equal to 16 a square plus minus 16a plus 4 will be half. So basically these were hypothetical. This was an hypothetical example. So we don't have values for such values for that. But similarly, we can find it in a way. You can see that. Let us try. We can factorize this part. So basically, we need to find such values that a plus b is equal to 11 and ab is equal to 13, 30. Right. So you can take the values maybe 10 to 3, no, yeah, you can take 5 and 6. 5 plus 6 is 11 and 5 plus 5 6 is also 30. So this is how we can factorize them also, and again this can be factorized using the splitting middle term method also that we have, I guess. We haven't learned it in the chapter 2, but yeah, not a problem. That is it. We have some more identities that you just need to learn, that is a plus b whole cube. So a plus b whole cube is written as a cube plus 3a square b plus 3ab square plus b cube. And therefore, we can write it as a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. You just learn it, and also you can derive it using the expansion formula, that is a plus b, a plus b, a plus b. So first find the square, then multiply the square with the normal bracket again. So I hope this particular part is clear, and we can move further. We have discovered some more identities such as these two. So basically, if we were to expand, you'll need these identities in your higher grades, not now, but yeah, for to understand it, you have to learn it. So we can write x minus y bracket into bracket x square plus x square plus y square. And if you multiply it and simplify it, we get it as x cube minus y cube. So sometime if you want to expand x cube minus y cube, you can directly expand it in this way, right? And the second part is equal to, that is x plus y, x square minus xy plus y square is equal to x plus x cube plus y cube. So that you need to try it on your own. Nothing much you have to do. You have to just open the brackets, multiply the brackets, and simplify them. That is, पहले x को multiply करो, x को x square, multiply x with x square, then x into xy, then x into y square, then minus y into x square, then minus y into xy, then minus y into y square. You may see that only we have a small difference of the sign, nothing much. So for the first case, it was x cube minus y cube. And for the second case, it was x cube plus y cube. Okay, cool. I think we are done with the chapter. Next up, yeah, we have a small part that is simplifying rational expressions also. So that is nothing much. If you are given algebraic expressions in a rational form, that is p by q form. Here we are given it as x square minus 7x plus 12 upon 5x square plus 5x minus 12 minus 100. If you are given that you need to simplify this rational expression, you have to do nothing, just split the expressions into their factors, or maybe into the just factorize both of them. Yeah, you will see that kuch na kuch bracket cut raha hai. You'll cancel out the brackets and you'll get the answer. You can see that if we factorize x square minus 7x plus 12, we can write it as x minus 4 into x minus 3. And if we factorize 5x square minus 5x minus plus 5x minus 100, we can write it as 5 into x minus 4 x plus 5. So you can see that the x minus 4 bracket literally cuts. So therefore we are left with x minus 3 upon 5 x plus 5. So basically we have reduced the rational expression. Pehle that was बहुत बड़ा and it was also in the form of quadratic. Now it has become a linear expression. I hope this is understood. The next exercise is on that only, exercise 4.5. And I think we are done with the chapter. So yeah, just we'll summarize what we have learned. Identities are equations that are true for all values of variables. Now we have seen that all of these identities are expression for are true, hold true for all the values of the variables. You can take any value. Okay, then we can visualize it using the algebra tiles. You have seen the picture in the book. Okay, you need to learn all of these identities. You can see that these are very big identities, and how will you learn it? You just first you solve them. You can, if you are clear with the logic, then you will definitely, with some practice and with some duration of time, uh, you will be you can by heart it, right? So these all are the identities, right? So yeah, and sometimes now for the whole chapter we have studied that it was in the form of a plus b whole square, and now you have x minus x plus y whole square. That doesn't matter, because again x, y, a, b, c, d, these all are they are all alphabets. They are all alphabets, and they are used to store the variables, where like we can get any value for the variable. Okay, I think we are done with the chapter. Go through the chapter once for the textbook, read the textbook, go through your class notes. If you have any doubts, please feel free to put it in the comment section. I would love to clarify them, and I'll try my best to clarify them. Also, if you have any feedback suggestions, you can put it in the comment section. I'll definitely try to incorporate those feedbacks into my teaching and onto my channel. Thank you so much for watching this video. Have a good day. Take care. Bye bye.
वीडियोस बनाने हैं, फिल्मोरा है ना।